Today we're going to learn about random coefficient. We learned already about the mixed models, but using different covariance structures. Now we're having more structures, but what is called random coefficient. So we have three models in the random coefficient. We're going to go over and learn some. So the same objective that we still need to cover here. For the first, here we're talking about random coefficient. So the random coefficient, basically we're talking about two parameters. One is called the intercept, the other one the slopes. Two parameters that we need to control for. Because we have seen that patients sometimes not start at the same level, like if we say blood level or blood lead level. So they have different, they can start at different measures here. So that means they're having different, this is the intercept here, all right? The starting value for every patient. Starting value, consider a coefficient, which is the intercept, all right? So these having means that this and this different intercept. So we're having three intercepts here, three different intercepts, okay? Also the slope. The slope, if it's parallel, then they're having one slope. So by looking at this, we can see these are never interact, never cross each other. So that means they're having one slope. Okay. So we need to model this using different intercept but one slope. Okay. So this is a different modeling that we need to consider so we can get our best predictions for this and reduce the error. So now these parameters, alpha and betas, need to be estimated. So if we consider it random intercept, that means we can have a different intercept for every patient. If we say random slope, that means we can have a different slope for every patient. If we have a random intercept slope, that means we're having different intercept, a different slope for every patient. You see that? So this is how we're going to account for. And then we're going to go over each one. You know how we produced this last time, right?
Yes.
This plot, so we can produce something like this. So ideally we're looking for something like this. This they're having what? Look at the intercept.
Common.
This common intercept. Common mean the same, start at the almost similar intercept, right? Look at this. And now, do you see any interactions between this line? They never interact, so that means they're having also common slope or the same slope. This is the ideally we're looking for something like this, but always this is not the case. Sometimes you will see when at the time point here they drop or they increase more. So you see some interactions. Once you see some interaction, that means it can be an issue, and you need a different modeling to account for a different slope, a different intercept as well. So you're looking at we're going to go over each one here. This is the random coefficient. It's called random coefficient. Why is coefficient? Because you have two parameters. These two parameters, the intercept and the slope, is called coefficient. So both of them is called random coefficient. But now you can categorize this into three. One you call it random intercept model, and now random slope models, and also random intercept and slope. So now here, for the last one, this is more flexible. You give a different intercept and you give a different slopes for every patient. For the first one, you're giving a different intercept for the patients, but the same or common slope. For this one, you're giving what? Different slope, but common intercept. You see that? Now for random intercept, so the random intercept assume that each individual has a different intercept. Simple. This is it's called random intercept. Okay, so but they're having a common slope. Okay, so which is allowing for a different intercept but a common slope. So that means they're having one slope but a different intercept. You can imagine how this line would be, right? So basically they start at the same, yes, but different. So now we look at this, how we run it, how are we going to model this in SAS? We're going to use the same product mix. We're going to use the same product mix. I'm in lecture right now. Okay, so now how we model this is called random intercept. So for random intercept, same using path mix. Okay, so you would name, you would class ID. I think you're familiar with this, correct? And then response, which is this is the outcome. Also familiar with this interaction. You need to finish this up. Exactly the same thing. Now, what is new for you? Instead of repeated, remember repeated statement, you're going to use random statement. So once you write random, SAS will identify that this is a SAS keyword. It will be blue. So now random, and if I'm trying to produce random intercept, you say random space intercept. Okay, slash, you give it the options. Subject equal ID. These are the same one. But now, if we're trying to produce random intercept, which is we're gonna tell SAS that give a different intercept for every patient, but a common what? A common slope.
How it's different intercept and they are always starting from the same one in the common slope?
The slope is common, okay, which is going to have a different intercept, but the slope is common. Slope is common means that they all parallel. They not interact. They not interact. Like one of them down on the yeah. So now by this, the random statement will tell the model that to fit a different intercept for every subject, but the slope are constant across subject. Constant, that means parallel. They never interact. And to make it constant, we have to use type equal what? Compound symmetry. Remember compound symmetry, what it will do? Yeah. Constant over time. This will fix the variance to be constant. So this is why we use type equal compound symmetry. So for the random intercept, you need to use the type. For covariance structure, the type would be what? The compound symmetry. Okay? Yes. So now this is, you generate the random intercept. Then to compare this model with the model already generated last week, remember? What you do? AIC. You look at AIC also in this model and compare it with the other model. Which one is the smaller? That if this has a smaller AIC, that means it's the best. If it's not smaller, then you choose the other one. Okay. Same thing, you continue doing this. Now this is random intercept and now random slope. It's just a different, right? Another one. So now here, the random slope, assume that each individual has a different slope. All right? But what? They're having a common intercept. So now likely you will see some interaction here, but they start at the same point, which is common intercept. All right? Yes. So and then how are we going to model this? Similarly, everything would be the same. But for the random now, instead of intercept, I'm going to put time or week or the time variables. You see that? And then subject equal ID, I'm going to remove the type equal compound symmetry. And why I'm removing the type equal compound symmetry? Because now we're going to allow for different slope. See the idea? So now here, the idea of this, we're going to tell SAS that give a slope for every patient. That means that every patient having a different slope. And to allow for this, we have to remove the type equal compound symmetry because we wanted to have a different slope for every patient. So we have to remove that type equal compound symmetry. And now we just put random equal the time here, and this will produce for me the random slope. Now you see the difference between random slope and random intercept. In random intercept, you're going to put, in random statement, you're going to put the intercept, right? And also in the type, it would be what? The compound symmetry. But for the random slope, in the random statement, it would be the time variables. Because you need to have some time variable where it could let you put a different slope for every patient. And then you have to remove the type equal compound symmetry so that now you will have a different intercept for every patient here.
طب كيف يكون شكل الراندوم سلوب؟ من الداخل؟
كجراف؟
لأنه المثالين اللي راحوا كان common slope.
عندك هنا مثلا maybe. So now for random slope, I'm just writing this by my hand, okay? Random slope. So what you do here, basically, for random slope, you will have a common intercept. This is the intercept here, right? It starts here. So their starting point are the same. It is a common. All right? And now you will see some point is doing this. And now you need to allow for different likely. Could be one at this time point increasing, but all of a sudden now become like this. And now here, starting here again, and all the common become like this. Remember, this is at the time variable, right? So the measure may vary over time. It can be increase, can be decrease. So now this is a different, this is slope, definitely different than this, right? So now this one slope, this is the second slope. You will see having a different slope here because they cross. They're having same intercept, but a different slope. So we need to have what is called random slope to account for different slope. Yes.
هذا إذا كان بدينا common starting point.
Yes, common starting point.
But our data previously last week wasn't like this.
Yes.
It was different intercept أصلا.
Correct. And also different slope.
We use this in assumption of what? We assume what? From a clinical background, not from biostatistician background.
You just not going to plot your data and you say, for this data I need the random slope. Visually it's hard always to judge that this model you need to use.
Last week it was different.
Yeah, but this is why you need to have to be more accurate. You need to use the parameter, the AIC. Remember that?
Yes, the smallest is better.
This is what it tell you more accurate.
The same idea last week. We will put all of these measure and we'll use the smallest one.
Yes. It is the same. Yeah. It is the same idea. Yeah. So now this is for the random slope. Same thing you could do it for the random intercept. So random intercept, if you're trying to produce something here, what do you think how it will be?
The intercept from different one, not from one.
Yeah, something like this, maybe. But they never interact. Yeah. So now these are huge difference here, right?
Yeah.
So this you need what is called random intercept. So that every patient will have a different intercept. Okay. Now another one, which is more flexible. Remember, just in this one, you need to remove the type equal compound symmetry, right? So now for this one here, basically you are more flexible. You are assuming both the intercept and the slope are random. So mixed model has a more flexibility to modeling this. So now you're going to include both of them. Look at this. The random variables, you're going to include the intercept and the time. But you're going to exclude what? The type equal. Because you still need to have a common, you need to have a different time, which is different slope and a different intercept. So you have to remove that, the compound symmetry statement. Yep, these are the three models. So we can produce them, and how we choose the best one? According to the smallest AIC, that would be our best. We can compare these three models with the model we already produced last week, right? And then choose our best model to present our data. So once you produce your best model, then the next step is to answer the questions, the research question or the final exam questions.
أيوة هو ده المهم. يعني one of the exam this one. Thank you.
يعني question يعني after we produce this one هنا كانت type compound symmetry مثلا ولا we produce also the different type
تعمليهم كلهم. طلع ال AIC كلهم لو وتقارنيها في tables which one is the best.
كلهم اللي أخذناهم structured
أنا بعطيك الآن كلهم.
تعطينا المعادلات هذه قصدي الكود ولا نحفظها؟
لا الكود هذا حقك.
الكود نحفظه ولا نجيب ورقة؟ من النهاية.
لا ما في ورقة.
خلاص حفظنا.
هم 5 6
كثير.
قول
مخ عصفور.
قول 9.
لا الاختبار حيكون زي المد برا اللاب ولا
لا حيكون في اللاب.
على
الأجهزة.
بس نحفظ الكود.
So
كل شيء. أملتنا في أول الترم إنه ما نحفظ الكود.
لا
وآخر من هنا حفظناه. من هنا حفظنا الكود في الاختبار.
So now you will have we're gonna talk about the final exam next week. Is it?
No, I didn't. I wasn't there.
No,
I came late.
next week.
لا ما.
نتكلم عن الفاينل exam next week ولا؟
Next
you
week.
want to finish this today
Today أحسن.
في class next week.
نيجي نسأل.
ها؟
لا ما في خلاص يعني
نيجي نسأل. ها؟ I will not be there, قصدي.
So